Okay, so the next question asks us to consider the following series and decide which ones converge. Okay, so we're going to start with the first one. Okay. So this series has a power of n in it, so we should think straight away we're going to want to use the root test because our entire term has a power n. Okay, recall the root test. For the root test, you consider the limit as n goes to infinity of the nth root of the absolute value of an. Okay? And if this value equals L, and that's less than 1, we have absolute convergence. If it equals L and is greater than 1, we have divergence. If it equals infinity, again we have divergence. And if it equals 1, it's inconclusive. Okay, so in our case, an, the nth root of the absolute value of an is just going to be 2n squared plus 7 all over n squared plus 1. We want to look at the limit as n goes to infinity of this guy. Well, if we divide top and bottom by n squared, this is going to be lim n goes to infinity of 2n squared divided by n squared is 2 plus 7 divided by n squared all over n squared divided by n squared is 1 plus 1 over n squared. And we can see this guy goes to 2, this one goes to 0 over 1 plus, and again goes to 0. So this equals 2. So we can see this limit is greater than 1. So hence, sum n equals 1 to infinity of 2n squared plus 7 all over n squared plus 1 to the n diverges by the root test. Okay, so for the second problem, we want to look at the sum n equals 2 to infinity of 2 to the 1 over n divided by n minus 1. So whenever you're faced with a question, you should think, what's making this strange? And the strangest object involved in this is 2 to the 1 over n. So I'd like to understand this guy's behavior as n goes to infinity. So what would that be? Lim n goes to infinity of 2 to the 1 over n. So this would be, because 2 to the x would be continuous, 2 lim n goes to infinity 1 over n, 2 to the 0 is 1. So in the limit, this guy is going to behave like 1. So we expect our series, n equals 2 to infinity of 2 to the 1 over n minus 1, to behave as if this was a 1 in the limit, n minus 1. n equals 2 to infinity. Okay? So we know that this guy diverges because he behaves like n equals 1 to infinity 1 over n. We know that diverges by the p-test. Okay, so looking at all this, we get the idea that we want to compare this series to this series. Okay? So let's consider lim n goes to infinity of 2 to the 1 over n minus 1 times. Now we want to consider dividing, because remember, limit comparison is an over bn. This is our an, this is our bn. So when we divide by 1 over n, it's the same as multiplying by n over 1. That's going to be lim n goes to infinity of, let's just separate this out, for n minus 1. I pointed out at the start that this goes to 1, and we can see this goes to 1. If you want to be more precise, you can divide top and bottom by n, show it goes to 1. So this goes to, both of these converge, so this goes to 1 times 1, which is 1. So now by the limit comparison test, I have this guy converges or diverges if this guy converges or diverges. So if this converges, then this converges, or if this diverges, then this diverges. We know by the p-test that this guy diverges. So hence, by the limit comparison test, we get that this guy diverges. Okay, so then for the last problem, we want to look at the sum n equals 1 to infinity of n factorial over e to the n. Okay, so we're going to use the ratio test for this, because if you see a factorial, then it's usually a good idea to try the ratio test. Okay, so what was the ratio test? an plus 1 over an, absolute value, n goes to infinity. So in our case, this is going to be lim n goes to infinity of n plus 1 factorial over e to the n plus 1. And then it will be divided by n factorial over e to the n. So we can flip e to the n over n factorial. This is equal to lim n goes to infinity of n plus 1 factorial is n plus 1 times n times all the way down to 1. N factorial is n times all the way down to 1. So just to write that out, it'll be times n minus 1, dot to dot, 1 over, and then the n factorial will be this, 1. E to the n plus 1 divided into e to the n is just 1 over e. Okay, and we see that we get all these cancellations. Cancel. Okay, so we're just left with the n plus 1 of, so n plus 1 over e. And we can see that that's infinity. Now, what does that tell us? Recall that for the ratio test, if this limit is less than 1, we get absolute convergence. If it is equal to 1, it's inconclusive. If it is greater than 1 or equals infinity, we get diverging. So hence, because we got infinity as our limit, n equals 1 to infinity, n factorial over e to the n diverges by the ratio test.